All right, I'll get started. My name is Raymond. I'm the evangelist for Disco, and I'll explain what Disco means later as well. The topic today I'll be focusing on is called intelligent video processing at scale. And Disco stands for distributed computing. So for us, we're very interested in how you can scale your solution without you, if you're a developer, to continually doing the DevOps side. So go straight to this part. Take a picture if you want to find me. This is the best slides you can take because I'll answer all the questions as long as you contact me. If not, I'm in trouble anyways. My boss is going to say, what am I doing? So please use that and then find me anytime for solutions. But more importantly, I think for all of you today is why I'm here. What is Bray doing here? Well, I did my PhD in computer science in Toronto quite a bit of time ago. So I worked for NVIDIA, Google for some sort of internship. I'm really interested in GPU stuff. And about 6 years ago, I did a company with the Y Combinators. If people did startup, it was pretty fun. Raised quite a bit of money. But more importantly, I always interested in creating system solution that's like, for everyone to use. And that's why glasses too. So I also give TED Talk. If you're interested, you can see my TED Talk one day. I was the first hologram at that time, called a hologram, interactive one with my founders. So let's talk about history a bit more, like with graphics. Like I am one of those guys I love to build. I'm a builder myself. And I build really many things, hardware, software. And that time was 2013. I was wearing glasses. As you guys see, glasses. That's my one day. Glasses like that, we have all the compute. But unlikely it will be here, it will be on the cloud, right? But I was wearing glasses that I wear, and I was on the street demonstrating. I was like Iron Man, guys. I'm not kidding. I have superpower almost because I can see in the dark. I can see things I cannot see otherwise in infrared. And I just don't do it for fun. I did it for research, but I bought it to the Valley. So at one point, you can buy my device. I've raised about $23 million there. Quite fun, seriously. And I didn't stop. I even built a second device called Meta 2. So this one has the largest field of view. So I built all the crazy system that actually does tracking, the optics. But bring it back to where the pain I had at one point in my life was 2012. That's my PhD thesis, by the way. I know, it's boring, PhD thesis. But that time, I did something really cool. You guys have the HDR video feature right now on your Samsung phone, right? I was doing that before that. I was trying to combining frames and make sure that you can do this. But at that time, I need a lot of hardware help. It worked with GPU, CPU, and FPGA before I can get the video out. Of course, I was excited. It's because it's research, right? I can do anything. But reality is, once you start touching them, it's like, oh. Less is more, guys. Trust me. I don't know if you should trust or not, but when you have a lot of source code, different dependencies, it's really hard to manage. The horror story where I don't remember what happened 2 years later after I finished all this fancy FPGA, GPU. It's very hard to change any bit of the work I did. And I was the only expert know how to do it because I spent 6 years on it. And I had a memory leak. Guys, what happened? The guy next to me said, I don't want to look at your source code, man. This is not my problem. Right? And that's what happened to most people. It's like, memory leak, not my problem. And collaboration is impossible. I became a loner. And time-consuming to every time update different platform. And I don't have money anymore for my research, right? I ran out of money. More importantly, I quit after I don't want to code until 2 a.m. But this is the industry problem. This is not my only problem. If you categorize all this, right? Scale, expensive to scale, special hardware, all this kind of maintenance problem, and more importantly, people quit on you. So this is the mission about Disco. Okay, bring it back to why we're here is we want to make sure that all the devices you have today should be our resource. No longer specialized hardware that only serve one thing. No, look at the number of cell phones today. It's just ridiculous, the amount of resource we have. And then, but the problem is it's so hard to use them, right? So Disco, we provide you the simplicity. If you have done the collab, you haven't, please go see our collab. We have an interface to show you how it works. And it's accessible. So today you have, let's say you're an engineer, you can have hands-on experience with it immediately. So I assume most people here knows how to do programming. I will go a little bit more in depth. This is a lecture. A little bit of a Python experience is always welcome. If not, it's OK. I was a TA before. I teach operating system and all that. That was even harder to teach, OK? So this is not too bad. Most workflow is like this. You have a Python script or some sort of script that helps you wrap around your work. And you have data that you upload. But what this code do is we take those information from you and give you the output, but we take away the hardest part. If you have a solution that you need to scale, you end up with storage, provisioning, security, and the worst case is like you never know when to scale more or less. Elasticity is hard. So this is actually the Colab you'll see, or the actual job we run on our server right now. This is this code web interface. So the way it works is very simple. You log into a website, you click the new job, you get this interface. So you get three things here. One is, well, the job, the name of the job. So you can say giant substance, wherever you want to call it. And then you drag in your scripts. And more importantly, you click a button, and voila, it runs, and you get results back. So to see in runtime, basically, this is exactly what you see on your screen. So we do provide you to auto-generating job names. So if you run an idea, you can generate fun names. And then I end up with a name called, I don't know, Roomy Lock or something. And you can talk to our engineers sometimes. The words are a little bit inappropriate. It's kind of funny. Now is to see, all you need to do is like, you can either run the job now or run it later. But once you create it, this is the fun part. This code handles the hard part. Where should I put the resource? Where is it? So we will basically, in the queue right now, it's like, OK, I have like 1,000 machine, 100 machine. Can be on-prem. Can be like on-prem means like it's your own managed servers. Or can be on our cloud server. Today, the one that we're running, we manage it for you. But once you're done, it's simple. You just download the results back as a zip file. And I assume most people know how to unzip file right now. But once you unzip it, you get the results back in it. So that's the lesson one. I'll say is like, if you just want to test out our solution today, you go to our web interface, you give it a try. It works. If you're a developer, you know that, of course, I don't want to click and drop and all that. We provide command line interface as well. So why is it important to all of you is, well, this line of code is all you need for this code for today. This is your bring home message, guys. Take this picture. This is all you need to run any jobs from now on. OK, I want to just change the way you think about AWS, right? I shouldn't say that, it's a bit. But yeah, but you can definitely do your jobs by running one single line of code. This line of code consists of create a job, manage the saving part. More importantly, it's just consistent. Because like on the web interface, and this is identical. So let me read it out. This code add is basically our command line. You provide the job name. The script is what you provide as the input. The download is basically I'm going to download the zip file back. Once you're done, voila, you get the file back with this interface. Of course, the interface is a bit weird. Don't worry about it. But on the website, you see, by running this line, you create this job that we do all this like click and drop E, right? So for the administrator, it's very good. Because you don't now have to like remember anything. You just run a script. OK, so lastly, programming side. OK, there's a free way to use this code, right? One is web. Second is like single line, which you should remember. Lastly is super advanced. Anyone use multiprocessing in Python here? I assume more of you have tried. If not, it's OK. I'm here to show. Yep, good. Thank you. You guys are experts. I'm going to show you the line that will do multiprocessing in Python today. So this is a library people usually use called multiprocessing library. You import it. You get a pool. Usually define some workload. So this time, I generically created something like a power of 3. Very simple. Then you create a pool. The pool basically is like, it will look for the resource. Like, for example, you have 4 CPU. It will look for those CPU as your workers later. And you have inputs, right? And that's the function you run usually. And will map to different CPU. They run in parallel. And voila, you get the results. If you do this with this code, guess how many lines of code change you need, guys? 1, 2. That's it. That's all you need. If you're trying to run this on a server, we basically abstract everything you need to know about what CPU means. You think about servers. You think about node. You think about workers. It's the same concept as like you think about individual CPU. Why is it beautiful is you just write the same code, minimal line code changes, but the rest we just upload to the cloud, and then we handle properly. So what just happened on the server side? You got to get deeper, guys. Just hold on to this one. This is how it works. We are the scheduler for you. We take a job and figure out where's the best way to put it into which machine. And that is one of the, remember by paying back the old days to handle all this like dependencies, hardware changes? We took it away for you. because we put our money and time to solve that problem as everyone can pull into. And this is scalable. The job is no longer contained by your architecture. You just upload, it will continue to scale, continue to scale. Every time a job, we spawn the job for you, we spawn the threads for you, we spawn all the resource. And someone asked me, how many resources? Tell me how much you need. We put a cap on it until it's reasonable for your business, right? If you're interested in a business talk, please come to me as well. This is the most complicated diagram here, so you guys can take the picture of it and then ask me later. There's no more picture from now on, okay? This is the last picture you want to have, is the architecture diagram. This will take me about 20 minutes, okay, you guys ready? It'll be a 20 minutes talk right here. No, I'm like 2 minutes. Python code, the way it runs on a server, it's just like a native Python code. We abstract it for you. You think about Docker, right? You guys, anyone use Docker? Docker is like a virtualized machines, right? VMware kind of thing. You contain all that so that we know, like, for example, by the moment before you run the job, we have an environment that we know, right? Virtualize it. But very importantly is, as you can see, this is the part you can scale, right? You have these kind of like scheduler that we handle for you. This is what's this code. But you spawn each of the agents. Agents is what installed to your machine or installed to your AWS today. And that's beautiful because you don't have to do anything. You just install one thing. And what this could do is we have now access to storage like AWS. This is your S3. It can be your, I don't know, Microsoft one, Google one, GitHub, anything, right? So we support these kind of external resources, and then they're very fast. But more importantly is now is, with this architecture, your cell phone can be your worker. Your laptop can be your worker. It can be your cluster, it can be anything. And this is useful because now let's think about the actual use. Let me slow down a bit. I need to drink some water. Whew. So let's think about use case. Like, what do we use it for, right? So I'm a startup guy. I love building things, right? Let's say all of a sudden I have an idea. Let's say 10 years ago again. I say, I want to do something really cool. I want to put something on someone's face. I want to do the AI emoji tonight. Now it's a big thing, of course, but 10 years ago, let's say. But today is still a big problem. And I want to use some machine learning tool, like recognize your face, and then put something on your eye. Let's say I want to literally augmenting eyeglasses on your face like this, right? Of course, like that, if it's that good. But because I released this app, now I have 5,000 active users, which is not a lot, but for a startup, you're pretty much dead. You cannot maintain the load, right? And you want to turn someone that like kind of weird looking into a cool looking guy kind of things. It turned viral. And then all of a sudden, like, you put more emoji there, and they become more viral. And that's what the company is, right? But now you have a huge problem. You're starved with no money, right? You don't have like money to scale the company immediately by buying all the server. And you have a performance time problem. Because everyone uploading video to you now, only like a couple, maybe I can do a queue right now. It's like, it may take like 5 hours before you get a video back. And then you're thinking, I'm a CEO. It's like, oh my God, I need to hire a team now. The guy is like nowhere, and I'm in the valley. No one wants to help me because I only have like, my budget is $20,000, right? So think about the algorithm first. We're engineers, right? Let's think about the problem, right? Where are we at, right? Well, the problem is like we have a set of database of images today that are coming in. And then the image, basically the operations, we load the image. We detect the face. And then from the face, we find the landmark. And then we want to augment graphics, right? These are parallelizable steps, as you can see. And more importantly is they run on standard set of library. Let's say this is my solution today, right? I don't innovate anything new except this is what people want to use. So when it's working, my team looks cool, right? Like that. So like, oh, everyone's gonna look cool. And this is the problem now. So from the business perspective, it's important because as an engineer, you have to think about how does it relate to your business. Well, every time I do this, I gotta do math, guys. I know, like, I love math, so do math, guys. Let's do math together. So math is 2 frames per second, right? What it means is every second you do 2 frames of work, right, on one core CPU today. But I have 3,000 videos. Now let's do the math. Then you have let's say how many hours of compute you need. What the math is, let's say every single video is about 30 seconds. Then I can only process 2 frames, so that means there's like 90,000 frames of videos. Then you multiply, it's 375 hours just today of compute hour you need. If you're not smart, you'll end up basically stuck because it may take you, like, I don't know, many hours before you can return the video back to the user. And no one wants it because nowadays everyone say, I want to share today. I can wait 5 minutes, but not 5 hours. No one wants to wait. Now here's the problem, is how do we handle this spike? This is the big problem, right? When you have your own architecture that you scale within your own perm, oftentimes you have 6 CPU, 10, wherever that is. Oftentimes when you have like a lot of users coming in, which is most likely people in the afternoon uploading video to you, you get stuck. And you have this kind of huge problem with utilization. Your resource is not shared, right? So you have to manage it. So one proposed solution is very simple. It's actually how some of the video company works today is event-driven based. What it means is every time there's an event like a video coming into you, you're capturing it, you think about, OK, it's an event that I want to push it to the cloud. And for us, this code will handle this very well because all you need to do is provide me the job and provide me the Docker image. Right? You remember in my Docker image or the virtualization, we need 3 libraries. OpenCV, the dlib, maybe TensorFlow, maybe some FFmpeg related. But more importantly is we distribute for you with the same Docker image. What that means is every Docker image will run the same job, and then it's predictable for you now as a manager. For you, remember the single line of command? Didn't remember it? I kind of memorized it after a second day of job. I joined about 2 months ago, guys. I memorized it so well, and I always type this myself. This is how I run 2 of them simultaneously. Same script, but different data. So if you are programming, it's very simple. Basically, you keep spawning these jobs, and results will look like this.
Get used to it. What's going on over there? Oh, no.
Yeah, they didn't fix it yet.
Time.
You guys have Galaxy phone, right? If not, you should buy one tonight. Anyway, let's get back to this part. Where am I? So you see, that's why it's viral, man. Like, that was super cool. If you can just make every single video cooler, it's a real startup experience. Guys, you can take this idea. It's free, OK? I'm here to distribute idea too. So what's next? OK, it's too good to be true, right? It's like, now what's next? Like, of course, there's more problems. If you're a developer now, you think about how to even optimize the maybe turnaround of, let's say, half an hour to 5 minutes to 1 minute, right? This is up to your decision of your business, like how you want to scale the solution further. But we support multi-core. What that means is every Docker image you run, you can have multi-CPU in there. So every job can support multi-CPU and multi-GPU. And this is the bonus part that I didn't teach you guys in my collab. Again, I got to keep selling the collab because I've seen some of you did my collab. Good work, guys. You got get tickets from me. But the key is, if the collab you can finish with the bonus, please be my customer, guys. This is a super fun time because we can now think about a supercomputer solution together. But to you, like if you come to collab again, why I'm mentioning is I provide you this example code. This is pretty much your YouTube kind of thing. You can basically create your own server. Does exactly this, right? I help you to split the videos into chunks. You give it to this code, but we'll take all this chunk into different servers. So in this case, 5 video chunks, 5 different servers with multi-core. We handle everything, and then you get the package back. It's a zip file. And you only have to handle one thing, how to merge. That is a computer science 101 problem, how to merge some data, right? I can do that. So, but the hard part is the in the middle part. That is like a PhD work there, we should take away for you guys. So this is scalable because now you can think about every user come in, you have this kind of approach, and you just keep spawning this. And the only cap you have to think about is your budget, how much money you have to put into your system, and how you can actually scale this with a cap of the response time. It's a business decision, which you can talk to our CEO behind here. Our CEO is right here, I just saw. So you can talk about the business and our product development guys, and they will help you to set up your business decision because we can help you to save time and money. Actually, it's right here. So Avi is right here, is our CEO. So right here, he's doing all the great work, and also here is right here. So let's get back to the single line command. I gotta keep teaching this until we all get it today, guys. Single line command. What is it again? This code add, this code with the name. But more importantly, this time I provide you a list of videos. And that's it. The rest of the command and all that is identical. If you provide me a list of input, I spawn different tasks inside the jobs. That doesn't make sense to people anymore, but whatever. It's like, inside. And then you will get results much faster by doing that. So again, you can visualize this command line is doing this. Now think about the problem statement again. Remember we said we have to hire a whole DevOps team to handle my server. Now I can do it with a couple of engineers if they know how to use our solution. Remember like how much money and time I had to worry about? Now it's pay as you go. You budget your work before you go with it. If you ran out of money before you run it, you don't run it, guys, by the way. Your business is dying anyways. So you don't actually over budget anyways. So you might want to make sure that you budget within the budget so that you don't kill yourself. But more importantly, This speed up is real if you do it right? If you're using our solution, you can get speed up that's significant to get a good user experience. I think for most startup fail, it's because they don't think about what the user feel like, right? And this can help you to improve that user experience side. Let me take a break again. All right, so there are more proposed projects. I proposed the first one today is the video processing. You can almost build your YouTube server tonight. You can build your own fun little startup tonight by downloading our source code. You can have it, get it great, guys. I don't know about the licensing, but go ahead and play with it. But the second use case, for example, is self-driving. How much data are we looking at? I don't even know anymore, guys. Like the number of cameras and all that. If you ever start doing this, come talk to us. I've actually been talking to a couple, and I would like to talk to more, because that could be one of the solutions for you to scale your processing. Doing the SLAM, you're getting all those plane detections, all the pedestrians. Name it, you had it. Talk to me. I don't have a PhD in that as well, so don't ask me too much. I just know most of the stuff, OK? The second use case I think is very meaningful for you all is customers, right? If you are dealing with your customers, your boss will need to know how well are they doing. Oftentimes, in-store experience today is getting smarter. Like Amazon Go, Samsung, everyone putting smart system or camera system to track or to understand the behavior. And to you, if you're a programmer, again, you're going to go through the same pain of jobs of analyzing things. Push it to the cloud, push it to us. We handle the work for you. And focus on your business perspective. And lastly is what I excited the most is AR, VR as well. I'm always in my blood. I will still wear funky glasses one day. It's like now you have this kind of photometric videos coming in. Like, you know how we watched movie today, later, maybe just like a hologram floating? I built that before, it was super cool. It's happening anyways. And then also the experience, like how you build like all these graphics. You can see from this device, I don't know how many cameras they have there already. But this often requires a lot of parallelization. And it's a good use case for you all if you're doing AR, VR. So, summary. What today we talk about is how to use our solution to deploy with Python, with the Docker image that I talked about. But more importantly, we can support multi-CPU and GPU without you going through the pain of supporting them. All you have to support is like how to change those couple lines of code to ensure your work align with our architecture. And remember taking the picture of the architecture, just memorize it a little bit. It's like, that's it, OK? It's easier than any of the schoolwork I've done so far, OK? I've done much worse, trust me, guys. Like all those like operating system courses makes no sense to me still. I was a TA still. Event-driven, think this way. You should not over-provisioning things anymore. You should pay as you go, because that should be the way you pay for server. If you just all do this, guys, we have enough money to host party next time. The disco is real, right? All the money you save is actual real party time. Sorry, is it a bad joke? I'm sorry. But cost-effective is a real problem. And we don't lock you down too. It's weird, right? I was like, well, you can use your Amazon still. You can use your Google still. You can use your own still. But we provide you a solution to manage your solution. And I think this is very good because like, we can always advance this solution together. And then even further is maybe you can help people in the third world. They don't have the compute resource. Share a resource for them, right? We're doing things for the good for the environment, for the industry. And then you can run this farm in Mexico. Maybe it's cheaper. I don't know, whatever, right? There's maybe a cheaper way to run your service from now. All right, this is going to get long, OK? There's no perfect solution, OK? There's some caveat. I'm here to tell you what should not do. Don't send this to the moon and expect my stuff work. I need network, right? Don't ever send something like real-time sensitive with this. It doesn't work. I'm sorry, guys, OK? I haven't figured it out yet. Maybe in the next 5 years, OK? I don't know yet. Today, I don't know. You don't do real-time stuff with this application today yet for various reasons. Because there's certain latency that we have to watch out for, how to do the serverless deploying. But the architecture of the design is important to you. Remember how I divided the work into chunks, and those chunks are certain size? Those are like a kind of trial and error approach you guys have to do. There's no perfect solution. There's always some trait. But the trait is very easy. You just manage those chunks. And for you, you do have a lot less constraint. If you're using Lambda, I don't know, should I keep saying other competitors' name or not? But you can use other solutions. Other solutions will have limitation much higher than what we provide today. And learn how to break those barriers and see if that makes sense to your business. And we don't have ways to know your algorithm weights yet. I don't know how long it takes. So don't run infinite loop there. If you don't know what infinite loop is, don't run it. It will not work. Infinite loop was stuck. So if you get stuck, your job will die. So there's still like algorithm side that you have to learn. If you're doing machine learning, make sure your solution converge, right? It can run forever. If you don't understand what converging means, come talk to me. I'm very helpful. I know articles. I wrote books. I do have books, by the way, guys. I'm not even kidding. I'm like one of those kids that got a lot of random things. I have a book I can sell later, but talk with me separately, not in this conference. So we love startups. We love people that are trying our system. We're giving out 500 hours today. It's actually real hours you can use for compute. Come to the collab to sign up. It only happens by invitation only today. I'm sorry, guys. I cannot do this like just like randomly outside. It's people that I meet today, we meet today. We can give out that 500 hours. What that means is you get hands-on experience today to try it. Everything I talk about runs. I'm not like trying to lie to you. It runs with the script that you can download, and you can just like try it. More importantly is we become a family together doing something new, right? It's like we can step away from those like kind of like every night trying to provisioning a server problem. And for people who don't know about Samsung Next, we are also a venture and also a startup kind of like side. So if you have startup idea, always welcome for me to pass you along as well. So startup, Next means actually is the innovation center. The CTO is also there. I'm technical, but not the expert. He's the ultimate expert. So today, if you have the ultimate hard problem, you can come talk to the CTO. He's so hard, and then you will find him. And please add me to LinkedIn tonight, and then please download the source code for fun. And more importantly is if you tweet me, I'll give you guys a coffee, okay? I mean it, okay? This is like a deal for you guys. And Q&A time. Any questions, guys?
With your parallel processing, how faster we can get on the average, like
on average, right? If you're really bad at it, you still get like at least like 2x if you know what you're doing, because like by definition, if you split up the job, that like basically we will help you to find it immediately. The question usually comes from your algorithm. So for example, your algorithm is very heavily data-driven, like you have to crunch a lot of numbers. Ideal, perfect. We can get up to like 1000x. Why? Because it's optimal for this service, right? It's like when you write CUDA code, GPU, same thing. You have a lot of like copy and paste instead of doing work, you don't get much speed up. So those are the ideal case. So, and then we can do those very, very well. And then the second way to think about is we have less limitation on the number of speed up too. As long as your work is like parallelizable, you can get to 10,000 as long as you have the money, guys. Like, I mean, we can spawn 10,000 node for you, right? We can do that, right? So that's something we can do. Yes?
Yeah, I just had a question that you mentioned that you're interested in self-driving car startups, but then also do not use Disco for real time. So I'm kind of curious.
Yes.
That's kind of,
I'll explain exactly. Yep, very good point. You don't want to have the self-driving car running by cloud service in real time to expect this to drive it. But there's a lot of behind-the-scene processing, like updating the map. You don't need that like immediately most of the time for certain things, depending on what you're doing. Depending on what you're doing, I know, I'm an engineer too, I know. Whew, be careful what I say here. But depending on your situation, a lot of tasks that in building autonomous driving, not everything need to be in real time in a certain way. There's a lot of tasks like, right, yeah. No. This is like the back end usually. And there's a lot of work there. I talked to a lot of companies. They do a lot of training like that. Like usually what they do is they create a virtual city. And then from the virtual city, they're trying to like retuning, refining your algorithm. Those are real stuff. Like your algorithm just like, they don't need real data. They just need to simulate. This is like perfect for us because it's not going to kill anyone. And it runs very long. And then the faster you run, the better off you will get your stuff on the market to try, then better off you have a better product. So that's how we see it. Good question. Good catch. You listen. That means like, man, you're good. Thank you. Yes, please.
A related question. Did you say that you offer an on-prem installation of people? And so I guess then that's a separate discussion on how many servers and pricing and all that stuff?
Yes. Usually, depending on your sensitivity, right? That's why I say if you have the sensitive data, I recommend you do the on-prem solution with us so that you have a closed network system so that you don't have to worry about any sort of like intrusions or some sort of people attacking you. And then that's why do you mind I go back to the slide? It'll take me a while, but let's go back to this slide. Because I think a good question always have a slide to answer. That's my theory. I pitch a lot. So hold on. Oh man, I spent like a month to do this slide, so I'm sorry guys. All right, but this slide is where I think you may ask me, right? The agency, right? You hear? This is the part that you can think about is this part. Like you always think about these kind of things can be your on-prem, but this is the Disco agents, right? This is where you control your distribution. So this line, for example, is what you want to do for your own system. And then we support our customer. By the way, we are a startup too in some way. Disco is a startup company, I call it, because we are new, we are onboarding customers. So we have excellent customer support, including myself. I'm like all in with you. If you have any question, let me know. We literally solve the problem with you. We have a software engineer in place just to do that. Sounds good? Yep, Amazon, I don't know. I don't know, but we do, at least today, okay? Sounds good. Yes? More questions? I can ask my life about the glasses. It can be anything random. No? Why glasses? Which part of my life? Like when I was young, I was doing glasses. You want to hear that? I can't talk about that. It's related to that. I have time, guys. And then I'll talk about that part a little bit because it's inspired me a little bit. It's about 12, hold on, how old am I? 35, so subtract 12, 13, 14. I was 21. I saw my professor wearing glasses, like digital glasses, like augmented reality glasses, like Google Glass kind of things. He walked around in the campus with a big computer. I was like, what the hell is he doing? So I was like, okay, maybe I should build one, right? He told me he can see Wi-Fi. I was like, okay, fine, you can see Wi-Fi. It's like, I can't. So okay, I will build something. So I ended up going to the research lab and then doing mobile computing. So that my first problem was actually this problem. I was 2006, 7. I have a web server that allow you to upload video and share to the world. Before YouTube, basically. I dealt with the same problem. That's why I'm inspired when I hear this code. It's like, hey, I've been through that crap. It's like my server never run properly. Right? And then I have 10,000 users or something like that. It was pretty crazy. So that's why I do glasses stuff, because I always believe glasses is the best way to see the world, and you can capture a lot of information. That's one of the reasons. Yeah. Yeah. What about you guys? What do you guys do? I have time. You guys not going anywhere until we finish. I have a lot of time right now. Okay, let me ask a couple questions. Maybe who's here is a software engineer? How many people knows Python? So you know what I'm talking about, right? You knew exactly what I talk about, right? Is there any typo there? I have one typo. Anyone pick it up? Anyone saw one typo there? No? You saw it? Yeah. Where? Where? Where is it? Where is it? Oh, next slide? Oh, I was on. Oh, yeah. I said, no, that's fine, that's fine. Yeah. But actually, the question is how many of you have been to the collab today? Anyone? The collab? I saw a couple of you. 1, 2, 3, 1, 2. Yep. Please do attend it because I want to give all of you, if you have time today, is a proper introduction. Yes. Yes.
Now it looks like you're still planning to build a solution in Azure and Google Cloud, that those will be supported soon?
Yeah, we got it. Yeah.
Would your pricing model be able to maybe say, okay, AWS is the cheapest for you now, but tomorrow we're going to switch you over to Google Cloud, and then we'll sort of act as an intelligence front end and route your traffic through the most appropriate?
Can I have your card? Because that's like an in-depth question with the CEO at the back right here. So you can see it's right here, like with the pointer, like the CEO right there. Actually, we talked about this solution already. Yeah.
I work for Samsung. I'd be happy to talk to you.
Even better. Okay. Yeah, we actually have Samsung Mexico come to us. They have so many GPUs. Like, oh, it's awesome, right? It's like they have GPU that's not doing work right now. Hey, install my agents. I I don't know who paid the bill, but if I can give this to, let's say, third world country, they want to do some processing, we're doing a good thing for the world, right? They're just doing nothing. You can share your resource, right? And one example. All right, if you guys don't have a lot of questions, what time is it? I would like to bring you all to the collab, and then just like, we'll do like a, I don't know, field trip together, guys. You want to see like a real demo? Can like take you all there and do a field trip. Yeah? Yes? Yeah, let's go. Let's pack up, whatever. Let's go. You can stay here, and then I'll bring you all the way to the collab. I'll do a real demo with all the solution together today. And then if you can have me scan your card right there, everyone will be very happy. All right, so please stay with me. Just make a line, and we go together.